Today's video will discuss Chapter 5.4, Solving Inequalities. So we're going to solve these very similar to the way that we solve equations, except that obviously the difference between an equation and inequality is this symbol, right? And so what this symbol is telling us is that this that is on the left, which is just a number, even though it's written like this, is greater than this number. So whatever x is, when I add it to 5, it will have to be greater than 12. Now, some people can solve this problem in their head. However, I want to make sure that we understand the process of how to go about solving it so that when these numbers change or become more difficult and you can't necessarily solve it in your head, how would I do it? So keep in mind, whatever I do to the left side of this inequality, I would have to do to the right side. Okay? Otherwise, I'm going to change the value of the two sides. So if the goal would be to get the x, or the variable, by itself. Again, I'm trying to isolate the variable. So I want to get rid of this 5. Since that is a positive 5, I'm going to do the opposite of positive 5, which is negative 5. Keeping in mind that negative 5 and subtracting 5 would be the same thing. 5 minus 5 is 0, so that would cancel out. Now I've got this x. Keep in mind that this sign needs to come down. So this side is still, so the left side is still going to be greater than the right side, and the right side now is 12 minus 5, and that is 7. So I know that x is greater than 7. Now keep in mind, if I were going to graph this on a number line, I could put the 0 here and the 7 here, and as we talked about, those are the two most important numbers to have on the number line, would be this number and the number 0. Okay, and then I know because of this symbol, it would have to be an open circle on 7, and I'm thinking of the numbers that are greater than 7. Those would be like 8, 9, 10, 11, and they're going to be on this side of the 7, so my line should go this way. All right, now let's talk about another scenario that might pop up. So if you think about now, I've got this number, which is 3, is greater than or equal to this number, which is something we're calling m, and then adding 7 to that. So again, I want to get the m by itself, so I'm going to subtract 7 from both sides. Okay, because I'm doing the opposite of 7, and I want to isolate this m. 7 minus 7 is 0. So I've got this m now. This sign is coming down. 3 minus 7 is negative 4. Now the problem is a lot of people leave your answer like that. However, if you think about the problem we just did, the variable is on the left side, and so I can always say x is greater than 7. But my problem over here is I can't really talk about the m because I know that negative 4 is greater than or equal to m. So what I'm going to end up doing is flipping them. I'm going to put the m on the left. So if I'm going to take this number and put it here, and take this number and put it here, then what I need to do is flip this sign. So I'm going to put the m over here. Since negative 4 is greater than or equal to m, that would mean m is less than or equal to negative 4. So I'm going to flip this sign. Okay, and now the key thing here is as you go from this step to this step, you want to make sure that you're not changing what it says. So if you forget to change this sign, you suddenly change what m is. So m is less than, negative 4 is greater than or equal to m. So if negative 4 is greater than or equal to m, we need to think of numbers that might work for m here. So numbers like negative 5, negative 6, negative 7 would work, whereas numbers like 1, 2, 3 would not. When I flip it, I want to make sure that's still the case. Does negative 5, negative 6, negative 7 still work here? Or did I make a mistake and suddenly change the value or the meaning of the inequality? And in this particular case, because we flipped the numbers and flipped the sign, this still says the same thing. And then if I were going to graph this, you wouldn't want to graph it until after you have this. Remember, the numbers I need to get on there are the negative 4, because that's this number, and then 0. And so the idea is that I'm putting a closed circle on negative 4, right? Because it couldn't equal negative 4, and I'm going to the numbers that are less than negative 4. So that's like negative 5, negative 6, negative 7. And so my line should be going this way. All right, now I want to talk about another scenario that comes up, and that is when you are multiplying or dividing by a negative number. So when you multiply or divide an inequality by a negative number, you need to flip the sign. Okay, now I want you to notice that in this particular problem, we subtracted numbers from both sides. We did not flip the sign here. Okay, so the sign remained the same. However, in a problem like this one, what I'm going to end up doing is trying to get the x by itself, so I need to divide by -5. Since this number is negative, this sign is going to actually flip, so it's now going this way. Okay, and that had a lot to do with the fact that the negative means opposite. Right? And so when I divide -5 to both sides, the sign flips. And so typically what I try to do is deal with the sign first. Should I flip the sign or should I not? So I move the sign down. I know that the sign flips because this is a negative number. If that number is positive, the sign won't flip. -5 divided by -5 is 1, so this is an x. And then 45 divided by -5 is -9. So I've got x is greater than -9. Now the best and easiest way to check to see if you did this right is to pick numbers that are greater than -9 and substitute them into the equation to make sure it's true. So typically I like to look for numbers that are going to be easy to multiply in my head. So if I'm thinking of numbers that are greater than -9, numbers like -8 and -7 and -6 would work. However, a number like 0 is much easier for me to multiply in my head, or a number like 1 is easier to multiply in my head. So if I wanted to, let's say, choose number 1, which 1 is greater than -9, I can put a 1 in here, and that becomes -5 times 1, which is -5, and then is less than 45. So the question is that statement true? If that statement is true and it checks out, then this is correct. If that statement is false, then you have to wonder if you did something wrong. And for example, had I not flipped the sign, my sign would be facing the other direction. So I would have numbers that are less than -9. So if you think of a number that's less than -9, that would be like -10. And had I put -10 in here, I would have gotten +50, and this would be 45, and I would have 50 is less than 45. And you can realize that that is not correct, which means you know you made a mistake. Okay, so that's an easy way for you to check to see if you're doing the right thing. Now, it works with division and also with multiplication. So in order to solve this problem, I need to isolate the b. And so I'm going to multiply both sides by -8. And when I multiply -8, right, so I'm going to go -8 to this side. And sorry, I don't have a lot of space, but I'm multiplying -8 to that side. -8 here will cancel out. But keep in mind that as I multiply by -8, it means the sign is going to flip. And so you'll notice I'm changing the sign now so I don't forget. This is b. -6 times -8 is +48. So I got b is less than +48. And again, let's pick a number that's less than 48. Or I guess less than or equal to, sorry. b is less than or equal to 48. So think of a number that is less than or equal to 48. Obviously, you could choose the number 48. But an easier number for me to choose would be something like 1 or 0. In this case, 0 is probably the best. I could put 0 in here, and I get 0 over -8, which is the same as 0, so I don't have to write this part if you don't want to, is greater than or equal to -6. And since 0 is greater than or equal to -6, that checks out, which means that I'm pretty confident that this answer is correct. All right, that's all I got for you on this chapter. Just keep in mind the confusing part that a lot of people have with this is they start flipping the sign way too often. You only flip the sign if you are multiplying or dividing by a negative number. So keep in mind if you subtract, that doesn't change the sign. And if you multiply or divide by a positive number, that doesn't change the sign. So you're only changing it when you multiply or divide by a negative number. Thank you for watching the video. Don't forget to do the problems on the bottom of the page. I'll see you in class.